The Invisible Vortex. How a swirling potential generates a straight-line flow. The core of this problem explores a fascinating relationship between two different types of movement: an outward-pushing flow and a hidden, circling rotation. The observable part of this system is a radial field that looks like spokes on a wheel, radiating in every direction from a single point. While these spokes point outward, the field is perfectly balanced. The strength of the flow decreases as it spreads out, ensuring that the total flux remains constant without any new field being created or destroyed in the space around the origin. The hidden swirl. To understand where this outward flow comes from, we look at an underlying potential field. This hidden field doesn't point outward at all. Instead, it swirls in a purely rotational pattern around a central axis. This relationship is much like a vortex. The twisting motion of the potential is the actual source that gives rise to the outward spray of the radial field. The Dirac string seam. There is a unique topological challenge in this setup. You cannot wrap a perfect swirl around a sphere without hitting a snag. Imagine trying to wrap a piece of paper perfectly around a ball. Eventually, you will have to create a fold or a seam. In physics, this mathematical break is called a Dirac string. It is an infinitely thin line where the swirling potential becomes undefined, acting as a topological seam for the outward flow. Interactive demos and examples. The breathing flow and the swirl. In the first demonstration, we see side-by-side views of the two fields. The radial field's arrows pulse to visually confirm that its flow is balanced. Beside it, the potential field is shown as a purely rotating swirl. This highlights that the twisting motion of the potential is what generates the outward radial flow. The shifting seam. A second example demonstrates that while we cannot get rid of the seam, the Dirac string, we can choose where to hide it. By adjusting a specific constant, we can watch an animation where the seam slides from the North Pole down to the South Pole. Interestingly, while the math break moves, the actual physical radial force remains completely unchanged. The comprehensive view. A final demonstration uses 4 synchronized views to bridge the gap between abstract concepts and physical reality. It shows the static outward force, the rotating potential,